Okay, we're going to start talking about topics in Chapter 11 now. And to begin with, let's do a little bit of a review here and start out talking about numbers. So we have this, so I'm going to set up a number line, and I'll start setting up numbers on here. Perhaps I'll have the natural numbers put on a number line, and this number line, these numbers, then would go on forever in that direction and increase by a whole number increment each time. And speaking of whole numbers, if we add 0, we have a whole number there. And then we talked about how the ancients decided that this wasn't enough when they were designing structures. They needed to break these down, and they had fractions. So you'd have something like 1/2 here. Perhaps 3/2 here, so on and so forth. And we can start adding fractions to our number line. Then we saw that we could go negative here, and also negative with the fractions, so on and so forth. I'm not putting every possible thing in. I mean, that would take us forever. And then we had situations where there were other numbers, like square root of 2, which I think falls somewhere around here. Put this above the line. Square root of 2. We had numbers like pi, 3.14, so on and so forth. And all these numbers made up the set of numbers we call real numbers. So this is then the real number line, made up of integers, fractions, decimals. I guess I didn't put any decimals in. Perhaps I could stick a decimal here, 2.25. Decimals, irrational numbers like square root of 2. They all make up the real numbers. Well, we could, so a fellow named Rene Descartes recognized that, he's at least credited with this idea, that you could take two number lines and place them perpendicular to each other, like I'm doing here. Maybe you would call this line the X number line, and this line the Y number line. And I pasted an image of Rene Descartes here over on the right. So he lived in the 17th, and well, actually he was born in the 16th century, and you know, around Newton, the time of Newton and such. And he was kind of a wild guy, I guess. For his time, he would carouse out late at night and end up sleeping in the mornings for long periods of time. And as the story goes, he was lying in bed, sleeping off one of his all-night benders, and he looked up on the ceiling and saw a fly walking around, and recognized that if he used this two-line approach, like we have here, that he could identify where this fly was. So suppose we have a little fly here. By figuring out the distance, some x distance here. I'm going to put that x1 distance here along the number line. So suppose this is your typical number line, and all the real numbers exist on this line. So he could choose some value, project down onto this x-axis, and figure out what the value is here, and then he could also project over here onto the y-axis. Let's call this y1, and the y-axis also has numbers. Real number line covers all these real numbers. So his position he could define by some x1 value and some y1 value. And we call this a Cartesian axis system. So I'm only showing the this axis system in the what we call, I say, the first quadrant. But really, this can extend both in the each of these lines can extend both in the positive and negative direction. So we could create a larger system here. So this is our x-axis. This is our y-axis again. So now we have not only positive numbers, but we also have negative numbers, and all the numbers in between, so on and so forth. Minus 1.5. And then the y-axis, the same thing. 1, 2. We could have minus 1 down here. Minus 2. So in our first quadrant, all the x values in this quadrant are going to be positive. All the y values are going to be positive. So for example, if I had a point here, I might call this point 1 for the x value, 1 for the y value. If I had a point over here now, perhaps a point right here, this would be the minus 1.5. And we always, it's a convention that we always state the x value first, minus 1.5, and then 2, because this corresponds with 2 on the y number line and minus 1.5 on the x number line. So this would be maybe our second quadrant, and the x values here are all going to be negative, and the y values are going to be positive. We could come down here to quadrant 3. Perhaps this is a point. So there's an infinite number of points we could create. This is the point minus 1, minus 2, quadrant 3, our x values again are all negative, and our y values are all negative. And then over here in our fourth quadrant, you'll see that the x values are all positive and the y values are all negative. So maybe the point here, 2, minus 2. That's how we use the Cartesian axis to locate points. So we could actually then be asked, if I were to ask you to plot 3 minus 1, you'd come over here to our Cartesian axis. Now, keep in mind, this is 0, 0, the center point here. We come over here and we count over 3 in the positive x direction. 1, 2, 3. And then minus 1 for the y. So this is considered like x and y. Minus 1 for the y term would end up giving us a point right here. So this point would be 3 minus 1. And we could plot any number of points in that way. So that's essentially the ideas that are discussed in chapter section 11.1.